Welcome back, guys. Today we have a 2017 Holden Captiva or Chevrolet Captiva. It's got 2.2 liter turbo diesel under the hood. The problem with the car, customers complain, is that service spanner light, that light comes on. Okay, where does that go? Up there, that light comes on, and then the engine revs goes up. It's idling higher than normal, to the point where it's actually dragging the car. When you put your foot down, she said sometimes you have to put the foot on the brake pretty hard to stop the car, something like that. So last time the car was in, what I did was, I didn't have much time. I just quickly scanned the fault, and the fault were there was few fuel related fault codes. Okay, I can't really remember, it's been a week or two, so I can't really remember what it was. I didn't keep the record, so I didn't diagnose it that day. I just cleared the fault, and yeah, so the revs was revving pretty high, about 1500, something like that. So as soon as I cleared the fault, the rev came down to normal and the light disappeared, and then it was okay. She took the car maybe one day, maybe 2 days later. I'm not sure how long, but pretty quickly she said the light came on and the engine is revving high again. Okay, now I'll show you quickly what's happening with the revs. So I'll just start the car real quick. All right, you can see it's starting just under 1000. It slowly climbs up and stays there. Okay, the temperature, I don't think this one has a gauge. There might be something on the setting, but anyway, the car is hot, guys. I did run this car a little bit before, and that rev stays up there higher at all time. Okay, and that service light at the top there, that stays on as well. Okay, so we're gonna diagnose this car today. We'll just put our scan tool maybe. Let's see what type of fault codes we get. All right, I've already identified the car. Just go and look at these trouble codes. All right, the trouble code is cylinder number 3. Injector exceeded maximum learning limit performance. All right, we'll quickly just do a freeze frame data search, see what kind of data it gives us. I don't know, for some reason it's not working. So according to this fault code, I'll just give you a quick definition what it trying to tell us. Okay, the scan tool, I can't really see the scan tool freeze frame data, but anyway, what that usually means is the computer is obviously adjusting the fuel volume of fuel injection, right? So computer is trying to compensate for wear and tear, whatever the case is, and it tries to do its adaptation, like in put more time to inject fuel or cut time to put less fuel, whatever the case is, but it has exceeded that limit. So now the computer has a programming, let's say from here to here I'm gonna put I'm gonna turn this injector on for this long, and it's constantly adapting to wear and tear, engine condition, mechanical condition, whatever the case is. And then now what's happening is that it cannot adjust it anymore, whether it's going up or coming down, as in opening it more or closing the opening the injector more or less. Okay, whatever the case is, trying to adjust the fuel injection. Now computer needs to see more and more of adaptation. It wants to adapt more, but that's what the programming in the software or the ECU is given it to do. Okay, so let's say from 1 to 100 is the adaptation. Let's say it has exceeded 100, or it has exceeded, let's say 1, so you can't adjust it anymore. That's why it flags the fault code. Okay, that's the definition of this fault. Now from here, I'll say probably let's go and check our live data quickly, see what you can see. So I'm going to start the car back up again. All right, now I'm just going to go to live data real quick, and I'm just going to look at the fuel system. All right. All I'm interested in maybe fuel pressure regulator, fuel pressure. That's the desired fuel pressure. Let's have a look if we can find a fuel pressure. And also I'm interested in the cylinder balancing rate. So pretty much that balancing, that's what they're looking at. That's what the adaptations for the injectors are, I believe. That's what it is. So our fault code says number 3, I believe. Let's go back to fault code quickly. Number 3 injectors, right? So here I'm just gonna focus on number 3, see what you can see here. All right, desired pressure and fuel pressure looks good, 34 megapascal. Cylinder balancing minus 21 for the number 1, minus 12 for the number 2, minus 8 for the number 3, and number 4 is about 43. So they do have different values, but I'm not too sure which one's the correct value. What I need to see, I have no idea, because every car is different. Every car, how they do it, how they show it on the scan tool is different. So I can't really give you a correct answer, which one's right, which one's not. So I don't think this is really helping me. If you rev it, usually they go to 0. So there you go. If you rev the car, it goes to 0. Release the accelerator, come back down to idle, and they start adjusting. Okay, and usually I'm pretty sure they do this balancing adaptation during deacceleration. That's what I've learned anyway on most cars, and I know for sure GM does that. Okay, I don't think we have a number 3 injector fault, but I don't really know what I'm looking here, so it's really not gonna help me. All right, one thing I quickly noticed, that every time I put my foot on the brake, right, the revs come down for some reason. Okay, let me just quickly pull the engine revs diagram data. Engine speed. Is there a desired? No desired engine speed. Okay. Just watch this data here. Okay, just watch that engine speed data. I'm gonna put my foot on the brake and the revs come down for some reason, and I'll release the foot from the brake pedal and the revs goes up. I don't have an answer for that. I don't know why it's doing it. All right, let me go back and select that fuel balancing again. Let me see if there's any changes when the engine revs are low. Okay, I'm looking at the balancing rate. Um, 1831 554. So number 3 is at hovering around 012, and I release the brake pedal, rev starting to climb again, and the adaptation values are changing a little bit, but I don't know what I'm looking at it here, so forgive me for that. Let me go back to live data. I just want to see any other data here on the engine. Maybe I just want to see what's the engine speed doing here. All right, desired idle engine speed. Okay, let me see what's going on here. So I'm gonna release my foot from the brake, and it is going up, and it is going up together. The desired idle is at 1400. That's what the engine is doing. All right, put your foot on the brake, it comes down. So actually the computer wants to see that. The computer is doing that for some reason. I'm not very sure here. Okay, all right, next thing we're gonna do at this point, I don't know what I'm actually doing. Like the last time, I cleared the fault and all the revs come back down and everything. I'm just gonna clear the fault. Let's see what happens. I'm gonna clear the fault. All right, as soon as I clear the fault, you can hear the engine revs drop back to where it's supposed to be. Let's go to live data now, and our spanner light is gone. Just wanna go to engine again. Just want to see that idle. These are idle again. Now these are idle and that one's looking good. So I'm just revving the car. These are idle is at 700 and it's coming down, no problem. Let's go back to the fuel data again. Let's see what we can see. Fuel system. I just want to go back to the same data and see if there's any changes. These are fuel rail, and the fuel rail pressure has pretty much stayed the same, 32, 33. Not too concerned about that. I'm just gonna go and have a look at this cylinder balancing. I hope that's what I'm looking at here. Cylinder balance means injector balancing. I'm not too sure. It could be compression balancing. I'm not too sure about that. But looking at this one, minus 11, 12, that was the same value we had before. I'm pretty sure that was the same value we had before. Again, I'm not sure what I'm looking at it here. Put my foot on the brake, release, nothing happens, and I don't think this fault code will come back just by starting on and off a couple of times. This type of fault code is a performance type fault, guys. They don't come back straight away. Sometimes it could take days, even weeks. Sometimes this type of problems to come back. The faults to come back on, the lights to come back on. So so the light hasn't come back on. I don't think we have a fault code. Let's just have a look. Trouble codes. See if there's any. No trouble codes so far. Let's go back to the same live data again. So selected, and all my data is looking pretty much same before and after the fault, but before the engine was revving a bit high, so I'm not sure. Now special function, see if there's anything here. Pressure regulator, learn, injector flow rate programming, fuel rail pressure, learn, high pressure fuel pump, learn. Nothing about injectors, I don't think. All right. Trouble codes, nothing's come back. Okay, that's all right. I'm just gonna quickly turn the car off and I'm gonna talk about this. Okay, so to me, it looks like the injector might be at fault. Okay, or it could be we have a compression issue, but the car's running good, the engine running good, sounds good, idles good. I don't see any hesitation, any vibration, misfiring. So to me, I don't think it's a mechanical issue, but also sometimes compression issue can give you exact same symptoms and same faults. I've seen that before. So I'll probably do an injector balance. Let's say if I can do an injector balance test, injector flow test, and maybe do a compression test. And that's the only two things I can think of. If the compression is good, I would probably say maybe just do the injectors. That's where I'm at. I don't know, I can't explain why touching on the brakes brings the revs down. I'm not sure, but it could just be engine is going into some sort of strategy where when you see that type of fault, computer wants to do that for some reason, probably, possibly. So that will be the next mechanical compression test and maybe fuel leak down test. Next step, we're gonna do a quick compression test using our scope, just a relative compression test. For that one, all you gotta do is just, I'm using channel A of my scope. There's two channel A leads to the battery positive and a battery negative. That's all I'm doing. That's all I'm connected to. Now on the computer here, we're gonna go to compression test, and we're gonna select 4-cylinder, and then we're gonna do the test. But for this one, we need to disable engine from running, engine from starting, as in we just want it to crank. So what you have to do is, if you go on the scan tool, see if you can see or not, go to the active test and this is, every car is different. Some cars you'll have this, some car you have to physically disable the fuel or the injectors, but on this Captiva we can go to fuel pump relay, right? And then we can disable the fuel pump right here, but we can't just turn it on and off right here. We need to start the car first and then turn it off. Okay, I'll just go and start the car. All right, so now the car's running. You can see up there. I'm gonna command the fuel pump to turn off. Right, the engine just stalled on us. Now we can do our testing. Now I'm gonna go to the computer and start my compression test. And I'm gonna go inside the car and crank the engine. Okay, on the screen you can see we got 100%, 99%, 100% and 90%. Okay, for some reason one cylinder is 10% down. All right, sometimes this test doesn't really, it's not 100% proof, but just to be sure, I want to do this test again. Okay, all right, I'm gonna go and do the test. Hopefully the engine is still disabled. All right, we're still coming up with 90% on one cylinder. So it is a problem, but I don't think it's a major problem, but definitely it's showing us that there is something going on with one cylinder. Now we're gonna go back to exit out of here. And now we're gonna go back to our Pico Automotive software. So for this one, I'm gonna use my amp clamp right there on the battery negative, and I'm gonna get rid of this connection for the battery, and I'm gonna use this number 1 channel to sync with my number 1 injector. When you're doing this type of test on the injector, any components in the car where there is too much voltage magnetic field, never forget to use the, I got what is this, a Pico 10:1 attenuator. You can buy all different ratios, but definitely to protect your scope and everything, all electricals, make sure you use one of those on the channel, on that channel you're using for that. In this case, the injector. Okay, I'm going to use that. So it will protect any high spikes of current magnetic field. It will protect my scope. All right, I'm just going to put one lead to the battery negative, and my one lead will go to my injector. So I don't know which wire is what, but I'll just go on to number one's a little bit difficult because there's this power steering pipe on top. So number 2 is pretty easy. So I'm just gonna go on to number 2. The green wire on number 2. All right, I'll just zoom it back in there where I'm working. So I'm just going on that green wire on that number 2 injector. So we are getting a sync from number 2. Now I'm gonna set up my scope. So channel 1 is, I got 10-to-1 alternator, and I'm just gonna go maybe just plus minus 200 volt. That should be enough. And I'll just go back to 1 second. And my channel 3, my channel 3 is my 2000 amps amp clamp on 2000 amps mode. So I'll just go minus 200 to 1000 amps. Okay. Now I'm just gonna go and crank the engine. I think our amp clamp is not turned on. Let me just turn it back on. All right, try that. All right, I'm not getting anything from my sync. Maybe I'll go to the other wire. The yellow one just below that. We'll try that. Now I'm still not getting anything. I think because we use a scan tool to disable that fuel relay, fuel pump, I think the computer is not, I think the computer might not be turning these injectors. All right, that's not gonna work for us. So what I'm gonna do is I'm gonna just disable this injector real quick. All right, so I'm just gonna take all the plugs off. I'm gonna set a fault code, but I don't care. Because a lot of the new diesel cars, when you see there's no fuel pressure or low fuel pressure in the rail, they usually disable the injector. Maybe that's what's happening. So pretty easy. The clip's a little bit different looking than typical, you know, electrical plugs, but it's not hard. You'll figure it out once you see. You just got to pull that tab out, and then the whole thing will pull out like that. Yeah, I'm not going to show you how to do this, guys. It's pretty simple. This time I'm just going to go to number 1 because I can access that right now. Just going to back probe. All right, I'm just gonna go and start the car now. All right, now we'll pause this data and we go back and have a look. Okay, this is the screen capture we got here. Okay, let's just zoom it back right in there. I'll probably start somewhere here. Let's grab couple. Anyway, it's a little bit difficult to understand here, guys. I may have to do it all over again. I'm not too sure what I'm looking at here. Alright, I'm not too sure. I'm gonna go to the other wire and try the same test again, guys. Okay, I'm just gonna go to the different wire here on the same plug for number 1 injector. Just trying a different plug, different wire. I think I didn't make a good connection there. Let's try again. Try that again. Now I'm still not getting this. I'm still not getting the result here. I'll just go back to that same wire. We got some weird pattern here. I don't know what that is. Let me zoom it in. We got some kind of pattern there. I can't explain what it is. Maybe because we're setting a fault code, that's why it's doing that. I'm not too sure. Okay. Not too sure here what's going on. What else can we do to identify which cylinder is what? I don't think there's anything else we can do without obviously running the engine. And if you run the engine, we're not going to be able to do a compression test. But let me get rid of this blue channel for a second. Let me get rid of that blue channel for a second. We'll just focus on this one. Let's see what we can see here. Okay, so my blue channel, sorry, the green channel. So we are picking, let's say around there. Let's start counting from maybe right there to 1, 2, 3, 4 cylinder right there. So that's my 4 cylinder pick. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. So you can see there's a consistency there. Every second cylinder here where I'm marking, I don't know which cylinder is what at the moment, but every cylinder you can see is a little bit lower than the other cylinders. So between here and here, between these two sections I made here, so let's say this is number 1, number 2, number 3, number 4. See that number 2 is a little bit lower than the rest. So now let's move on to the next one. Let's say this is number 1, 2 is a little bit low, 3 and 4 is good. And let's go back to the other one. So let's go, so right there, that's, we just checked. Same thing, second cylinder is a little bit bad. Now let's go to the other one. This one doesn't look too bad, but you can see it's definitely a little bit lower than the rest. Let's try that. 1, 2, 3, 4. Definitely you can see it's a bit lower. And let's go here. And then 1, 2, 3, 4. Again, number 2. It's definitely looking like number 2 cylinder is a little bit low on compression. But is that enough to cause that fuel compensation issue? Not too sure. Okay, so the 10% difference we're seeing on that initial compression test we did, right? It's definitely showing up here, but we just got to figure it out a way how we can, we got to figure it out how we can identify which cylinder we are looking at here, guys. So definitely we're gonna have to do that. So that pattern tells me nothing. So let me see if I can figure it out somehow. Maybe we set a fault code, that's why it's not showing us what we need to see. I'm not sure. So let me just figure it out this, and if I did figure it out, then I'll get back to you guys. Okay, let me just, guys, I'll quickly show you my setup here. I still have my amp clamp on the battery, getting a relative starter current. Now what I did is I put my amp clamp, 20 amps amp clamp on a number 2 injector, because that's the one I can get to easily, with it all connected. So it took me a while to figure it out, but I think this is the only way you can sort of get that sync we're trying to do. Now this is our fuel inlet from the fuel tank. It goes right on top of that fuel pump right there. So I just disconnect that, put a rig, connect that to the pipe and excuse me, into my fuel can fuel jar. Okay, because every time you crank the engine or turn the key on, it's gonna the fuel pump in the tank is gonna push the fuel to the high pressure pump, right? Not only that, so then I also, what I did here is I put my little resistance wheel. I think I am giving it about what is it, about 330 amps right there. So you can change this resistance, you can turn it around and you can give it a different resistance to the circuit. So what I did is I disconnected my just grab a light real quick. So right here, what I did, I disconnect the fuel rail pressure sensor. The yellow wire is my signal for the fuel pressure sensor. So I back probe that into my resistor and I'm giving it to the earth right here, bolted to the engine there. So basically I'm changing the fuel pressure manually for the engine. So engine thinks that there is, I'll go and have a look here how much pressure I had it there. Just go to the live data for fuel pressure, fuel again, and then I'll show you right here the fuel pressure. Fuel pressure here. So the fuel pressure right now is sitting about 247. I think we disconnected that by touching it. Let me go and check my connection again. There you go. I think we moved that connection while I was touching it. So 7.9 megapascal, that's what I am giving it to the engine computer. Computer thinks it's got 7.9 megapascal of pressure in that rail while we're cranking. Because what was happening is the engine computer was disabling my injector turn on signal whenever there is no fuel in the rail, or whenever I disconnect the injectors, it wasn't giving me the signal that I wanted for injector turn on. So that's why I had to rig up all this, and then finally it let me do it. So when I had the pressure higher than that, so I was sitting about 28 before, through my resistance wheel I turn it up 29 psi. It wasn't showing me injection pulse. It was showing me some weird waveform. I don't know what that was, but it wasn't giving me all that. But after I put it down to 7.9 megapascal and then I cranked the engine up, now I can, the engine computer is giving the signal to turn on that injector. Now I'm not going to do it again because it was pretty difficult to set all this up. So I've already captured the my data up on the screen, and I'll just explain to you what I'm doing right here. we were suspecting there's one cylinder is a little bit low on compression, right? So this is the capture I got. So let's put 720 degree. Let's go from, maybe capture from there. Just follow my cursors on the screen, guys. So from there to there, we got 4 cylinders. So 1, 2, 3, 4, back to 1, right? So now I've already looked up the firing order for this engine is 1, 3, 4, 2 is the firing order, guys. Okay, so let's and I'm syncing on number 2 cylinder. So that's my number 2 injector turn on right there on that channel 4, which is the brown color at the top here, and this is my relative compression from the battery terminal, battery cable. Okay, so number 2, firing order again. So 1, 3, 4, 2. So 2, 1, 3, 4, back to 2. So again 1, 3, 4, back to 2. 1, 3, 4, back to 2. Okay, so this is showing me everything I needed that I couldn't do before, basically. So now, before we said that we had one compression looking a little bit lower than the others. Okay, so if I just put a cursor on top of that relative compression just for this one cycle, you can see that number 2, number 1 and number 3 is a little bit low. Then back to number 1, 3, sorry, 2, 1, 3, 4, 2. So number 4 is good, number 2 is good, number 3 is looking a little bit low. Okay, same thing again. Here again, if you count this 2, 1, 3, 3 is looking a little bit low compared to the others. Again here, number 3 is so looks like the number 3 is definitely a little bit low on compression. Okay, next step we're gonna do a fuel return analysis. So basically on top of each injector you can see this return line coming out, going this way, and it goes back and hooked up to the back of the fuel pump. So all I did is I disconnect that from the fuel pump right there, and I put my little adapter there to go to my pressure transducer right here, and I got the outlet from the other side of the pressure transducer, just yellow hose going into my bucket there. Now I just put a little jippy tight there to open that valve, so we need to be pressed. This valve needs to be pressed for this port to open, for the return to go out. Okay, so I'm on range 3. Usually that's enough. For range 2, they don't make too much pressure, maybe 1 to 10 psi, between 1 to 10 psi depending on the engine. Also I got a number 2 injector still hooked up to my amp clamp for the sink, and we're gonna just start the car and see what kind of back pressures we got. We're just gonna start the car now. My scope setup is my channel B is WPS 5000 range 3, 500 range 3, between 1 psi, and my channel D is my amp clamp for the sink. So we're just going to start the car now. It's always a good idea to let this yellow hose bleed out. Sometimes there will be a little bit of air, so just wait till all the air's gone from the yellow hose there. Now on the screen I'll just change that time scale a little bit, maybe go 100 milliseconds. Alright, this is only making not even 0.1 of a psi. on that back pressure. You can't really see much, so I'm just going to scale that up a little bit so we can see it a little bit better there. I'll just pause that and we'll discuss about it. Okay, looking at this waveform on the screen, we can see this is my number 2 injector firing, so it's safe to say this is our sort of top dead center around there somewhere, and this is my number 2 top dead center again. So every time number 2 firing, that's where you get that waveform up there. Now down here, that's the back pressure return. So this one will be after the injector firing event. So this one right here, I'll just zoom that a little bit more. So after the injector firing, this is my return pressure from our pressure transducer. This is for number 2, after the number 2 is firing. If you remember the firing order, 1, 3, 4, 2. So this is my number 1, this is my number 3, 4. Back to 1, 3, 4, 2, back to number 2 here. So I'll just put a cursor there. So this is my lowest value and this is my highest value right here. There's not much difference there. If you consider the pressure here is we're only talking about 150 maybe 0.5 to 0.50, 0.5 to 0.1 of a PSI difference there, right? But see how this pattern is keep repeating. So every time we say this is number 3. So 2, 1, 3, 4. So number 3 here is higher. They all look different. They're not very similar, right? But definitely my number 3 is looking a bit high. My number 2 my number 1 and number 4 is looking pretty similar right here and right there, but my number 2 is a little bit low and my number 3 is a little bit high, and this pattern keeps repeating. Okay, so if you can see, this number 3 is higher all the time, every time it keeps repeating, and number 2 is lower at all time. So I'm thinking maybe number 3 injector is a little bit blocked. Okay, and also we got a number 2 that could be a little bit leaking. Okay, that's what I can interpret with this waveform. So still it's pointing us, like the fault code, number 3 is at fault. And like we already verified, that number 3 also has a low compression. So it's, yeah, is it a compression issue or is it the fuel injector issue? It's a little bit hard to say, but they're both pointing us to the same conclusion here. Number 3 is at fault. All right, guys, before I give you my diagnosis, my conclusion, I just want to quickly read through this information. This is directly from the GM. This is what the factory manual say. Luckily I found this, so I'll just share it with you. So this is the fault code from P02CC to P02D3, which is basically number 1, 2, 3, 4 injectors, but we only had the fault code for injector 3. That's fine, this covers all of that. So basically this one will give you fault codes. I think the fault code we had was the D1. Description of the fault, you can read there. The engine control module monitors the correction values for the energizing time of each injectors. The correction value for the energizing time is learned for each injectors at 2 different rail pressure operating points. The energizing time of the pilot injection is adapted at 2 calibrated rail pressure points. That's the condition when the computer monitors that fault. Condition for running the DTC is basically operating temperature, battery voltage has to be up there, intake pressure, and it does at the very bottom, deacceleration fuel cutoff is active. That's when it does its monitoring. Let's go to the next page. And setting the DTC is a fault is detected when the stored corrected energizing time exceeded the calibrated threshold for greater than 1 second. So basically it sees that maximum value exceeded of the adaptation or correction. Now this is all more information there. We don't really need to worry about that. It does say over here the diagnostic is stored in the ECM over a period of time. The time to set this DTC may take several drive cycles, so it's not something like it's gonna quickly come back. It's kind of like a performance fault, so it could take anywhere from 1 day to several days to hundreds of kilometers. That's what it's pretty much suggests. All the information I've found. A bit more information there, but if we go to the very last page here, it talks about all the injection cycles and all that. We're not too worried about that. So right here, this is information maybe important for someone looking for it. The ECM will perform 1 injector learn per hour of engine run time in the firing order when the conditions are met. The minimum time to complete 1 injector's learn is 7 seconds, but can be excess of 50 seconds. Slight engine mechanical knock noise may be audible to the driver during this procedure. Up to 6 learn attempts per injectors may be made. If the attempts fail, the ECM will test the next injector in the firing order. So some more information there. I don't think this information is very important, but I'll just get you guys to read that. Maybe someone wants to see it in the future. Now at the, what else we got here? Alright, so basically the factory wants us to do, they're basically talking about up here diagnostic aid. The diagnostic parameters is stored in the ECM. Contaminated or improper fuel quality may cause the DTC to set. Worn base engine components or differences in the cylinder compression may cause the DTC. And all that, and to really, they really wants you to do basically check if the fuel quality is good. Right here it says make sure no aftermarket performance enhancing device has been installed. Any aftermarket chips, all that, make sure it's not there. And down here it says on the system testing, perform an engine compression test. If the engine compression is not within specification, repair as necessary. If engine compression is within specification, replace the appropriate fuel injector. So basically that's the only really test they give you, and I looked everywhere to see what's the threshold are for these injectors, for the correction values, and I could not find any information like that. And this is all they gave you to do a compression test, and if the compression test is good, change the fuel injectors, right? That's the GM factory manual there for you. And I also found this interesting case study. This is from a TAT magazine. You guys can go and subscribe to TAT, Automotive Australia, the automotive technician. If you Google that on the internet, you'll find them. You can subscribe to them, their website, and it's got a lot of good information there. So all I did is I went in there and just put Captiva in there, and I was looking for any information if I could find, and this is what I found. So basically this gentleman had the same car, Captiva, and it was coming up with the fault code P02D1, which is cylinder 1, fuel injection offset learning value. So it is the similar fault, but for number 1 instead of number 3, right? So basically what this gentleman found, there's a lot of things in this article, but basically all this pink highlighted area here, basically the gentleman did a compression test, relative compression test, which come out pretty good there. There is a little bit of variations, but again, it's only a relative compression test. We're not actually going into the cylinder, so which is looking pretty good. So what this gentleman basically did is he started taking the injectors out, and he found the nozzle was dripping with fuel. So number 1 injector, and more surprisingly, all the other injectors had wet nozzles and were dipping as they were pulled from the cylinder head. All right, and he just gives us a picture here, what he done and all that. So basically, they replaced the injectors, and also down here, as I was reading it, the vehicle would also sometimes idle at 1400 RPM, which was another part of the puzzle that was not now finally making sense, because overfueling from the leaking injector would no doubt lift the engine RPM. I don't know if that statement is 100% true, but definitely we do have that similar symptom of idle being high at 1400 when you first started recording this video. Okay, so basically these articles and all the findings we saw, I'm thinking we probably should do the injectors. I am not very 100% sure about these guys. I don't have enough information, and I can only do limited test, and what I can do, all the information I gather. I think what we're going to do is we're going to change the injectors, and then we also let the customer know, hey, that your engine is also engine also has some compression issues, like we saw on number 3 was a little bit low. It's only about 10% less, which usually I don't think cause problem. Or that also could be because this number 3 injectors is leaking, as we did confirm with the back leakage test earlier. It's also possible that the cylinder is washed more than the other 3. That's why we're getting a little bit less compression on number 3. That's very possible. But I don't see any other symptoms as in because of the compression. I did off camera some pressure testing on intake, exhaust, also blow by, and also head gasket, and I don't see any sign of compression being leaked out. So we do keep that in the back of our head, and we probably let the customer know about that, but at this moment I'll recommend changing all 4 injectors. Depending on the customer's budget, we can probably only get away with number 3 injectors, but I do highly recommend doing all 4 injectors at the same time. And also this car only had 77,000 kilometers right here. So I would say it's pretty early. 77,000 kilometers is pretty early, but again, you never know with cars these days. So that's what I'm gonna do, guys. Forgive me, I couldn't give you the solid proof on what's gonna fix this car. Again, this is not that type of fault where the fault comes back straight away. You're gonna have to drive 200-300 kilometers or something like that, I've read somewhere, in order for this fault to come back. Also on this Holden document, they did say that it takes several drive cycles right here for the fault code to come back, as in the computer takes time to monitor it. And also somewhere else we read that every hour of driving, computer does its testing. So it's not gonna be an easy diagnostic, but all the information we've gathered, I'm 90% confident that this injector is gonna fix this problem. Anyway, guys, that's all for today. Thank you for watching, and I'll catch you next time.